Okay guys, so here's number 5, and then we're going to do numbers 7 and 8 together in this video since we didn't get to it in second hour. Third hour did get to it. Now I'm going to show you two different ways to solve this problem. Alright, one of the ways is what we were doing in class, but it does take forever, as you guys can see in second hour. So I'm going to give you guys a hint first. One way that you can solve this problem is when you see basically like a binomial in one of the denominators. It doesn't matter which one. What you can do is you can try to use complex conjugates, because sometimes that can help us to get rid of things. Okay, so this is one way. So basically I see that there's a binomial here, so I'm going to multiply both the top and the bottom by the complex conjugate of this, which is secant of theta plus 1. And then the bottom, so right now I'm basically only going to be working with this side right here. And then secant of theta plus 1. Alright, so now like I said, I'm going to work with this side and I want to try to get it to equal this side. So when you multiply this, I'm not changing the problem because remember this is just 1, correct? So when you multiply this, you end up with cosine of theta times secant. I'm going to change it right off the bat to 1 over cosine of theta plus 1. And then the bottom is going to be secant of theta minus 1 and secant of theta plus 1. We'll work with that in a second. Now, up here, what I'm going to do is I'm going to distribute. I'm going to distribute that cosine of theta. So now this becomes cosine of theta over cosine of theta plus cosine of theta. And then all of that is over. What I'm going to do down here is I'm actually going to FOIL. Okay, so I'm going to FOIL this bottom one, and this becomes secant of theta times secant of theta, which is secant squared of theta, times the outer, which is positive secant of theta, and the inner, which is minus secant of theta. So what happens to secant of theta? It's gone. And then the last is going to be minus 1. Next step. So now what happens to cosine over cosine is it turns into a 1. So this becomes 1 plus cosine of theta. And then the bottom portion, secant squared of theta minus 1, is the same thing as using our Pythagorean identity. What is secant squared of theta minus 1? That's just going to be tangent of theta. So I'm going to rewrite that as tangent squared of theta. And you can see that I basically got this side to equal that right there. Now, okay, I understand that this one says cosine of theta plus 1, and this is 1 plus cosine of theta, but I can flip this around if I wanted to be cosine of theta plus 1, because they're both positive over tangent squared of theta. So that's one way. Another way, so I have another problem right here. Another way is to, when you see a proportion like that, you can cross multiply. So when we cross multiply, we end up with cosine of theta plus 1 times secant of theta minus 1 equals cosine of theta times tangent squared of theta. So at this point, if you want to press pause on the video and try to solve this on your own and then go from there, that's going to be the best way to study. Alright, so I'm going to continue. Right now what I want to do is I want to change all of my secants and my tangents down to sine and cosine, because that's really going to be the easiest thing for us to do. So right now I'm not working with one side, I'm going to be working with both sides at the same time, but I can just work with this side first and then continue on with this side. So here I have cosine of theta plus 1, and then this is going to become 1 over cosine of theta minus 1. So on this side, I'm going to have cosine of theta times sine squared theta over cosine squared theta. Now, since I decided to convert them all to sine and cosine, I'm not going to change this to the Pythagorean identity. I'm going to use the quotient identity. But if you use the Pythagorean identity, it will still work, but it'll just take a few more steps. Alright, so here I'm going to FOIL. So when you FOIL, you got your first, which ends up being cosine of theta over cosine of theta. Your outer, which is minus cosine of theta. Your inner, which is plus 1 over cosine of theta. And then your last, which is minus 1. So this, of course, becomes 1. And then what happens with this guy and this guy is 1 minus 1, so that's gone. So now we have minus cosine of theta. And then the only thing that I can do with this to maybe fix it in a little bit is change it back to secant. But right now I'm just going to leave it for you as 1 over cosine of theta. Alright, I'm going to come back to this side and see what I can do to fix this. Now, because this is division and there's multiplication going on, I can cancel out this cosine with one of those cosines. So this just ends up being sine squared theta over cosine of theta. Okay? So now the only thing that I can do with this is basically change sine squared theta. Since I have all cosines here, I'm thinking that I want all cosines to be on this side as well. So I can use the Pythagorean identity and rewrite this as 1 minus cosine squared of theta over cosine of theta. Okay? So this right here is split up into 2. I could put them all in 1 to make it look like this, or I can split this guy into 2. So I'm going to do that. I'm going to split this into 1 over cosine of theta, so basically just split the denominator, minus cosine squared of theta over cosine of theta. So what happens here is this cosine is canceled out with one of these cosines, so we have 1 over cosine of theta minus cosine of theta. And what do you notice? We have the exact same things on both sides. So if I wanted to, I could just simplify this down, but I don't have to because I've already proven that this side equals this side. Because the 1 plus cosine of theta, 1 plus cosine of theta, negative cosine of theta, negative cosine of theta. But just to clean it up a little bit, I can change this to secant of theta minus cosine of theta, and that equals the same thing here. This becomes secant of theta, and this is minus cosine of theta. So we have just proven the identity, that they're both equal. I can go on and show you a third way, but you've seen what happens in class, that working with one side with this type of problem, it's going to take us a long time to get to the final identity that we want. So these are two different ways to solve this problem. I definitely suggest, picking one and seeing which one you're better off with. With these specific trigs, this was much faster, but maybe with another trig function, this could be faster. So you pick which one you're more comfortable with. Alright. Now, number 7, I'm also going to show you two different ways to do this. So remember, in class I kind of said pick the side that you think is harder, and then work with that side first. So the first way I'm going to solve it is I'm going to work with the right side. I'm going to try to make it look like this. So if I did that, if I thought this was harder and I did that, the first thing I can do, the only thing I can do at this point is basically I notice that there's like terms in both of these terms. So I'm going to take out a sine squared theta, and then you're left with 2 minus a sine squared theta. Alright, so I'm going to pay attention to this side as I'm working. So I notice that I want to get it to look like this, so there's cosines here. So I can change these to cosines because we have sine squareds, I can rewrite this as 1 minus cosine squared of theta. And then in here, this is 2 minus 1 minus cosine squared of theta. So I just change the sine squareds. So you can already see that it's kind of looking the same. So now I have 1 minus cosine squared of theta. And then here we have 2 minus 1, which is just 1. And then this negative, of course, gets distributed to both. So this negative and negative become plus cosine of theta. So I've proven this in 3 steps, that this side looks exactly like that side. Alright, so that's one way. The other way, now I'm going to work with the left side. So this is 1 minus cosine squared of theta and 1 plus cosine squared of theta. So I want it to look like this. I know it's alpha, I'm just more comfortable writing theta, so it doesn't really matter. Alright, so the first thing I want to do, I notice that on this side they're all sines, so I want to try to make this side all sines. So this is definitely the Pythagorean identity, so this is just sine squared of theta. This is not the Pythagorean identity because there's a plus here, so it's going to stay 1 plus cosine squared of theta because I can't really do anything with it at this point. The next thing I can do, I still can't change this. If I change this using the reciprocal identity, I've changed it to secant, which is not what I want. That's not what this side looks like. So I'm going to try to distribute. So this becomes sine squared theta plus sine squared theta cosine squared theta. So again, I look at this, but when I did this step, I noticed, wait a minute, I can't really do anything with this. Alright, and I'm showing you my mistake and how I fixed it, okay? So I did this and I'm like, okay, so I can maybe rewrite this as sine squared theta plus sine squared theta, and then maybe I can rewrite this using the Pythagorean identity, and I know that the Pythagorean identity for cosine squared theta is 1 minus sine squared theta. And actually, yeah, it's not even a mistake. I mean, I can continue it just like so. So now I can distribute the sine squared theta. So this becomes sine squared theta plus sine squared theta minus sine to the 4th theta. And then I combine my like terms. So I end up with 2 sine squared theta minus sine to the 4th theta. And there we go. I got it to look like this side. Okay, now I'm just going to show you why I thought it was a mistake, just because when I was doing it before doing the video, I was like, okay, I distributed, and then I was like, maybe if I don't distribute and then change it, but I still ended up with the same exact answer. This is what I'm trying to tell you. There are different ways to get to the same exact thing. So this was 2 different methods using both sides that I thought were equivalently difficult. Alright, now number 8, I'm going to do it over here. I'll pull this up in one sec. So number 8, we have cosecant of theta plus cotangent of theta over tangent of theta plus sine of theta equals cotangent of theta cosecant of theta. So obviously the harder side to work with is right here. You could also choose to cross multiply this as well, because you do have technically a proportion, but I'm going to do it this way. And the first thing I'm going to do is convert all of these to sines and cosines. So here I have 1 over sine of theta plus cosine over sine of theta. All of that is over sine of theta over cosine of theta plus sine of theta. Alright, so up top, you notice I have the same denominator, so I can just combine these into 1. So this becomes 1 plus cosine of theta over sine of theta. All of that is over. I need to get a common denominator here. So how do I get a common denominator? I multiply the sine of theta by cosine of theta over cosine of theta, because that's the common denominator. So I end up with sine of theta plus sine of theta times cosine of theta. All of that is now over one denominator, cosine of theta. So we have a double fraction, so flip this guy and multiply. So we end up with 1 plus cosine of theta over sine of theta times cosine of theta over sine theta plus sine theta cosine of theta. Okay? So basically what just happened, before I do anything, the next thing that I could do, I could combine them all together if I wanted to, so I guess we could do that. So this is 1 over cosine of theta times cosine of theta. All of that is over sine of theta from this times. Now here, what do you notice I can do to this to simplify it? I notice that both of these terms have a sine of theta in them. So what I'm going to do is I'm going to take out one of the sines of theta. So I'm going to take out a sine of theta. And now what's left is 1 plus cosine of theta. So what do you notice? These cancel out completely. And the only reason I can cancel them out is because this whole entire thing is being multiplied by this. So I can cancel this out and cancel that out. Alright, I'm going to move up here. So now I'm left with cosine of theta over sine squared of theta. Alright. I could change this back into the Pythagorean identity, but I need to continue to pay attention to what I want on this side. And if I'm looking at this side right now, if I wanted to rewrite it really quick, okay, this side is basically, what is cotangent? Cotangent is cosine of theta over sine of theta, and then cosecant is 1 over sine of theta. And guess what this side is? If I break up those sine squared of theta, I can break them up into cosine of theta over sine of theta times 1 over, still have one more sine of theta, because remember this is multiplication, so I'm just multiplying. And then what do you notice? It looks the same thing as this side. So I can stop here because I've technically shown that it's the same, or I could have continued and called, okay, so this is cotangent of theta times cosecant of theta. So I could have continued this and shown that it equals this side. Done. Okay. Now, with this specific problem, starting on this side, I could have started just like I did right here, but this would have been as far as I can take it on this side. So that's why you always want to start with the harder side, the more complicated side. Okay? So I've put up a homework assignment on iLearn. You should definitely work on that. And then if you want to do more problems, use the textbook assignment and do this up top. You do some of these. In class on Monday, we're basically going to be going through multiple examples, as many examples as we can get through. Good luck.